Hello, guys. Welcome to another episode of CUDA Education. So, we are continuing our path of understanding the modern renderer, and we have basically our application that we've been working with. It's a beautiful scene that shows us, you know, uh, some really nice architecture, and most notably for this video, we're dealing with volumetric scattering, which has a lot to do with sort of the fog and the quality of the fog that we see. So, we have this, you could definitely see it with the light, right? You have sort of, this nice ambiance of things. And, as we proceed further, it changes depending on what's going on around it and all of that stuff, right? So, um, what we want to do is we want to turn off the volumetric fog, or the volumetric scattering. We want to turn it off and then see what happens when we turn it off, right? And when we turn it off, we basically see that things get very plain vanilla, right? There's no real ambiance in terms of the fog, in terms of what's going on with the air, all of that stuff. It's just very plain and generic and stuff, right? So we don't want that. We want we want this volumetric scattering, right? But we're going to seek some assistance in terms of what exactly it is and all of that stuff, right? Quick video today. I don't want to get too in depth in code because I was in depth in code in the last episode, so I don't want to do that here. But so let us do so let's look for so this is the high level variable that we toggle on and off for the volumetric scattering in the code, right? And then we do an if statement that basically gives us different parameters for what we, how we want this volumetric scattering to execute, right? But what I want you guys to do, and what sort of is the future and stuff, is we're going to use the agentic coding feature in Xcode 26.3 in order to help us learn what volumetric scattering is and what this particular piece of code is, and what each feature in in the if statement is doing, right? So in order to do that, we basically click on the star here. Now, if you guys want to be able to run Codex or your agentic coding tool in Xcode, number one, you need to make sure you're on the latest Mac OS operating system. So update your operating system. Number two, you have to turn on Apple Intelligence. Number three, you have to get an Apple developer account so that you are able to it's a free account, so that you're able to go into the Apple developer portal and download the beta version of Xcode 26. Basically the beta version of Xcode 20 Xcode. So the beta version of Xcode is 26.3. You have to do it in the developer portal. If you go to the App Store and download Xcode, you're only gonna get Xcode 26.2. Word on the street is that by the end of this month, which is February 2026, Xcode 26.3 should be launched into the App Store as just the regular Xcode. But right now, you have to go into the developer portal to download the beta version / the release candidate, right? Because it's still in beta. So 26.3 is the only version of Xcode that allows you to run your model. Now, you could run by default. It gives you access to like sort of ChatGPT stuff, like Codex / ChatGPT stuff, and Claude, which is from Anthropic, right? However, you can add your own personal or other models. So you could add in Gemini. You kind of have to go through a process with like an API key and all that stuff. In order for you to run Codex, you have to have, I think for the normal ChatGPT prompt, you don't need a paid account. But if you want to run Codex, which is OpenAI's coding specific um, agent, you have to have a paid account with OpenAI. Okay, so I have a paid account, and that's why I have my, I'm able to run Codex here. Okay, so first of all, let's just, so we just press this thing here, and then we do what is volumetric scattering, right? And we sort of get an idea of what it is. Now, it is aware of the code and the text and stuff that the project that I'm working with. So that's pretty cool. We don't have to copy and paste as much because it's sort of aware. Volumetric scattering is how light interacts with particles in a medium like fog, smoke, dust, or mist. Instead of only bouncing off surfaces like hard, objects, light is absorbed and scattered within the volume, which creates effects like visible light shafts, God rays, hazy depth, soft glow around bright lights. In a renderer, scattering volume typically means simulating that light transport through the air itself, not just the surfaces, right? So we kind of see that already with turning on and off the scattering, right? So then one of the things you could do with this feature is you could highlight a block of code like we're doing here. So we already know it's testing whether volumetric scattering is turned on and off. If it's off, then this if statement fails, and these constants and parameters and stuff, are not available to the shaders, and things aren't processed and stuff. We're not going to dive deep into code with this one. We just want to get a small piece of how this works. I am in the AAPL config file under the renderer tree, right? So what you can do is you could go to, it's editor, and then you could go to show coding tools, and you could do explain. And what it will do basically is it will take what you've highlighted, and then it automatically puts it into the agent, and then the agent will tell you exactly what each of these things are, right? So it's kind of project aware, it's context aware. You could just highlight a piece of code and do explain, and then it will give you an idea of what's going on here. These lines define compile time constants for the scattering volume feature, and they're only active when use scattering volume is enabled, which we saw, right? You either toggle it 0 for off or toggle it 1 for on. What it does and how it works: if use scattering volume, and if conditionally compiles the block, if use scattering is 0, none of that, right. So tile size sets a 2D tile size in pixels used for the scattering volume grid. A value of 8 means the volume is broken into 8 by 8 screen tiles. Scattering volume depth, so that's this guy right here. Sets the number of depth slices in the volume, a z dimension for the grid. 64 slices mean the scattering volume is a 3D grid, tiles in x, y, and slices in z. Scattering range, defines a view space depth range covered by that volume in scene units. Here it's 100. F meaning the scattering volume spans 100 units from the camera along view space. Important details. These are macros, so they're resolved at compile time and typically used to size GPU resources and to configure dispatch sizes and shaders or whatever. Shaders or CPU side setup code. Changing any of these values alters memory use and performance. Smaller tiles or more depth slices increase resolution but raise costs. Larger values reduce costs but can reduce quality. This block only exists because it's enabled earlier in the right. Okay, so for a couple of these, I for a couple of them, I don't really see a change. So like for the tile size, right? So let's do tile size. I think Yeah, I didn't really see a difference with tile size. So let's go to the scattering range. I definitely want to do that one. Scattering range defines a view space depth range covered by that volume in scene units. Here it's 100F, meaning the scattering volume spans 100 units from the camera along the view space. Okay, so let us play with that. All right, let's do a baseline first. So we're gonna do the baseline first of what it is just by default, right? We're gonna do the baseline first, right? So we have this guy right here, and we see the fog sort of at a certain level, right? Now, if we now cut this down to 1, right? And then we run the scattering range. Let's see how the application changes. Okay. So we see that units from the camera, right? So I'm going to assume now that, based on the stationary place of the camera, that we're not going to see much difference. So everything is bland because it's like literally not very far, not much far from the camera. Okay. Let us do 25. Okay. So we're going to run this again. At 25, we probably will see some difference, but it might not reach across. Oh, it did reach across to the light. Okay, so this is pretty much like what we had before, right? Let's just do 10, right? So let's do 10 and see what we get. Okay, so we kind of see a difference here where we see some fog, but we notice that we don't see the halos on the lights here, right? We don't see the halos. We see some fog, but not the halos on the lights, right? Let us zoom and do 1,000 now, right? So let us see what happens when we do 1,000, where literally we're applying this thing to very far into the scene from where the camera sits. Okay, so notice that now, everything is kind of beaming, especially the white light, right? Well, all of them actually, it's just that we can't see it as much, right? But we see that everything is beaming. We don't really see much difference in terms of performance of the in terms of moving the camera and stuff and the frame rates. But we do see that we have that, okay? So let us do 10,000, right? And let us see what we get. And this shows what it shows, okay? But notice that when I move the camera around, I don't see much struggle in terms of processing and stuff. So, we'll have to investigate this further at another time. I just want to sort of see what's going on here. You could sort of see all of this, what's going on, right? So that's volumetric. That's scattering range for you, right? That's scattering range for you. So we've played around with that, and we see what that does. All right, so let's go to the number of depth slices and scattering volume. So scattering volume depth. Let's see what is the definition for scattering volume depth. Sets the number of depth slices in the volume, a z dimension for the grid. 64 slices mean the scattering volume is a 3D grid, tiles in xy and slices in z. Let us see what happens when we change this. Well, actually, let's just go back to baseline first, right? Let's go back to baseline, so we have a baseline of what we're looking at initially, right? So this is our baseline again. We're back to normal. Everything looks good. All right. Everything looks good. So let's now do increase. We'll do it 200. Okay. And then we'll see how the scattering volume depth changes anything. Okay, first of all, we notice that there is some heavy processing going on because when I toggle my camera, notice that it's very laggy, right? So that's definitely a thing. Even when I'm moving forward, it's like slow, right? But yeah, that's that. If we do 1,000, we're gonna see that things are gonna change even more. And we see this behavior here. I can't even move the camera too much. The struggle and the frame rate drops meaningfully. You know, I can't even when I try to move forward. And then if I do 5, hold on, I don't know if I did it properly. Yeah, so we have this behavior here. But the frame rate improves, you know, back to normal. But we could see that we have this bubbling thing, which we'll have to investigate. So anyway, that's that. The scattering tile. Well, first of all, let's get back to baseline. All right, so we're back to baseline, right, guys? We're back to baseline. And then we're going to increase this to 35. And as I said, I don't think this changed much from what I understand. Oh, right. It causes an error. So we'll just do 1. Okay. Can I do 5? All right, so, you know, that doesn't give us much. That doesn't give us much Just need to make sure I'm back at baseline. Yep, so we're back at baseline, okay. So that's it, guys. Volumetric scattering. So, I just wanted to sort of play around with this. I didn't want to get heavy into code today because I was heavy in code yesterday. But at some point we'll dive back into it. But this is the APL config file. We set the constant, we enable it with a 1 or 0, and then if it's enabled, we set all these constants that are used in the shaders and all that stuff, right? I definitely find that the Codex is pretty cool. It's generally direct. It gets to the task at hand. I find ChatGPT, the general ChatGPT, to be a lot more. It's a lot more verbose in terms of explaining stuff. It's a lot of text, a lot of reading, whereas I find Codex just kind of very direct to the point, which makes sense because you're actually in the weeds in code and you don't really have much time to be reading a whole essay on what's going on. You want to just focus on the things that are important, and it tells you, and you do what you have to do. So that's volumetric scattering in Apple Metal 4. Make sure that your system can run Metal 4, and this is a free. Just Google Metal sample code and look up modern renderer, and you'll be able to download this code for your system and run it. I also provide a link down in the description. So let me know, guys, what you think. Let me know if you're trying to run some agentic coding. Again, even if you don't have a paid subscription to ChatGPT, you could still, you won't be able to run Codex, but you'll still be able to run ChatGPT in this window, and you could just copy and paste code in there, and it wouldn't necessarily have the context, so you might have to paste the entire script into ChatGPT, or like communicate the project somehow to ChatGPT. But it's a start. But yeah, this stuff is actually pretty helpful. I can't knock it. It is very helpful, and it does what it's supposed to do. I generally like Codex. So there you have it, guys. Xcode 26.3. This is Code Education. Learn Metal in 2026. Don't let the whole year go by and you don't know Apple Metal. At least a baseline understanding of how it works and stuff. And yeah, guys, thank you for watching. Like, subscribe, encourage anyone that's artistically inclined in your community to get involved in this stuff. Metal is pretty straightforward, and now you have all the tools in the world to help you learn it, right? So there are no excuses. Thank you for your time. Have a great day.